So we are reviewing some skills of absolute function to get ready for calculus. Now here is question 1 from absolute function worksheet. It says graph the function f of x equals to x squared minus 1 divided by absolute x minus 1. So now absolute function is a piecewise function, right? So first let's define this absolute function. It could be written as absolute x minus 1 is equal to two pieces. One is x minus 1, it is positive if x minus 1 is greater than or equal to 0, and it is negative if x minus 1 is less than 0, right? Or we can write this as it is equal to x minus 1 if x is greater than or equal to 1, right? Bringing this minus 1 on the right side. Or we can open this bracket and say minus x, or let me write minus outside itself, x minus 1 if x is less than 1. So that is how we define our absolute function. Now, since we have defined like this, it is a piecewise function, we'll actually see it in two different pieces. One, when x is greater than or equal to 1, and the other, so this is x is greater than or equal to 1, and the other half when x is less than 1. So our function will change in both these, right? So what is going to be our function? Now, the function f of x can be written as, if it is less than 1, then we have to take negative value. So the denominator will now be negative of x minus 1, correct? Numerator is x squared minus 1. It is difference of squares, correct? So I could actually write this as x plus 1 times x minus 1, correct? Over absolute x minus 1, correct? I'm just trying to save space and give you a few steps here and there. Okay? So I'll use this numerator in the factored form here. And I'm writing this as x plus 1 times x minus 1. Now you can see x minus 1 and x minus 1 will cancel, and we are left with minus of x plus 1, correct? On the other hand, when x is greater than or equal to 1, in that case the function will be, numerator is same, right? X squared minus 1, which can be written as x plus 1 times x minus 1. But the denominator will be positive, correct? X minus 1, correct? And therefore x minus 1 will cancel out, and we are left with x plus 1, correct? So that is how we see that the two parts are different. You see that? Now we can graph this function, correct? The whole idea was to tell you that the function actually is as good as x plus 1 on right side of 1 and minus of x plus 1 on the left side, right? So here is the graph. So basically I'll first sketch the line x plus 1. X plus 1 basically means this is your x, right? Y goes to x. Shift it 1 unit to left, right? Or y-intercept is at 1. So well, we'll draw a line here saying this is my line and this line is x plus 1, correct? But the function is, let me use a different ink. The function is x plus 1 when x is greater than equal to 1, right? So when x is greater than equal to 1, the value is 2, correct? It's kind of here. This is when x is 1. At that point, if x is 1, right, f of 1 is, what is f of 1? F of 1 will be 1 plus 1, which is 2. So at this point, the value is 2, correct? Now, so if x is greater than 1, then it is same as this line. You see that? It is exactly same, and that is okay. But if x is less than 1, if it is on this side, in that case the line gets reflected. Do you see? It is in that case equals to minus x minus 1. Do you get it? So this line from here to here gets reflected. So instead of 1, this y-intercept will be at minus 1. Do you see that? And the line will be, now let me just go down here. The value is minus 2 where we are going to have the hole, right? So let's say this is the hole, right? And the line will be actually reflected, right? Like this. So imagine that this blue line is reflected into x-axis, giving us the other half of the curve, right? And therefore, our graph for the function f of x will be as shown here. So, from 1, this point is included here, and the other half is here. So that is how the function is going to look like, correct? I hope you understand and appreciate. Now, the absolute function. So that is how a function is going to look like, correct?